In this lesson, you will learn how to programmatically control the user interface in LabVIEW NXG. Let's begin by learning about VI Server. VI Server provides programmatic access to LabVIEW and LabVIEW applications. VI Server performs many functions. This module concentrates on how to use VI Server to control panel objects. VI Server has an object-oriented architecture that is platform-independent. Each object that is part of the VI Server is part of a class. The class that the object is part of determines what an object can do, what operations or methods it can perform, and what properties it has. Objects can be things like a stop button, a push button, a numeric control, or an array. Panel objects inherit their properties from the control class. This class has subclasses where the objects are defined by their data type. For example, a stop button is an object of a Boolean subclass of the control class. Now that we understand the basics of the VI Server class hierarchy, let's discuss how we can use VI Server to modify a panel object. Properties are single-valued attributes of the object, such as its color, position, size, visibility, label text, and label font. Properties can be read or write, read-only, or write-only. Let's take another look at the class hierarchy that we saw a few moments ago. The stop button inherits the properties associated with the Boolean class, which in turn inherits properties from the control class. This is useful because you can rely on the stop button having the visible property from the control class. Think of a class hierarchy as a template for defining states and behaviors that are common to objects. Now that we have an understanding of VI Server and properties, we can discuss how to use property nodes to change the characteristics of panel objects. A property node reads and/or writes an object's properties, allowing you to programmatically change them. For example, using property nodes, you can enable wrapping for a string control, change the trace color on a chart, or disable or enable panel controls. Let's explore how we can create a property node to disable the numeric. In order to modify a panel control or indicator with a property node, you must first create a control reference. To create a control reference, select the controller indicator and click Create Reference. Note that if you do this from the panel, you will find the control reference in the Unplaced Items tray on the diagram. Now let's place a property node onto the diagram and wire our control reference. The property node adapts to the class of the control reference input. Now we can select the object properties that we want to read or write with this property node and create controls and indicators. Let's place our control and indicator onto the panel and run the VI. Note that the numeric indicator is now grayed out and the visible LED is on. If you want to use a sub-VI to modify the object properties, you can create a sub-VI that includes the property node but not the control reference. This can be useful if you want to modify the properties for a variety of panel objects at the same time, such as when you're initializing a VI. Property nodes are expandable and have multiple properties. Property nodes execute from top to bottom. The first time this node executes, the old value for the tip strip is read and passed to the indicator. The new value is written but not read because property nodes execute from top to bottom, and the write terminal executes after the read terminal. If you run the VI again, the tip strip string, this is a numeric control, displays. If an error occurs on a terminal, the node stops at that error, returns the error, and does not execute any further terminals. The outputs return the default value for the data type. For example, here we are modifying and reading properties for the x-axis of a graph. We have set the minimum value of the range to be greater than the maximum value. When we run this VI, an error occurs because the minimum cannot be greater than the maximum. Therefore, format returns an empty string and no values are written for the mapping and fit type properties. You can also use duplicate terminals to initialize control and indicator values on the panel. Let's start with a review of how to initialize control and indicator values each time the VI opens. Let's specify the default values for those controls. Amplitude is 1, offset is 0, and frequency is 5. This means every time I open this VI, these controls will be set to these default values. However, if I change the values, leave the VI open, and run the VI again, then the controls will not reset to their default values. To initialize control and indicator values each time the VI runs, use a sequence structure and duplicate terminals. First, I'll create a sequence structure. Next, I'll create a duplicate terminal for every control that I want to initialize. Now I'll change these duplicate terminals into indicators and specify their initial values. Then I'll use an output wire to ensure that the sequence structure will finish executing before the rest of the VI starts running. Now notice that if I run the VI, it programmatically initializes these controls. You have completed this lesson. Here's a summary of what you learned.